and throw up the slideshow, Katie.
Everyone see my screen?
Yes.
Okay, perfect.
There's a random phone number that we should mute that's got background noise. There we go.
Nice. Thank you for that. All right, well, welcome everyone to the first quarterly forum that we'll be having after the guide has been released, which was just over a week ago now. We're excited to have all of you here today, and we'll have a hopefully a very full discussion about both the guide, the pilot, some leadership strategy, things that are going on that open up some opportunities for all of you. But we're very excited to dive into these topics of the guide's creation. And then we'll also have a panel discussion with a few exciting folks who've been a part of both the guide and the pilot. Kim?
So welcome everybody. I know we have a number of first-time attendees, and we want to welcome you here. If you are so moved, go ahead and tell us about yourself a little bit in the chat. You know, who you are, where you're from, and if this is your first meeting or not. We're really happy to have you. These lovely and charming 11 faces up on the screen right now are your steering committee, the soon to be reconstituted steering committee. So this may be the last time that some of these faces appear on the steering committee slide. So I want to thank each and every one of them for the dedication that they've shown over the past months, getting MEP 2040 stood up and having had what I think is already a significant impact on our industry. So our mission is quite simple. We are a movement to radically reduce total carbon emissions associated with building systems through collective action. And this forum is a great example of that collective action. When a firm signs on to commit to the MEP 2040 challenges, one of those challenges is to attend and participate in these forums. And they happen every 90 days, plus or minus a little bit. And we spend some time talking about what's been going on with the commitment and work of the commitment during that time. And as Kaylee mentioned in the agenda, this time around, we're really going to be focusing in on the newly released Embodied Carbon Guide for MEP systems. We call it the Beginner's Guide because, quite frankly, I think most of us are, even the ones that worked on the guide, are still beginning to understand the impact of embodied carbon in MEP systems and equipment. And this is really important work, and we thank you all for the role that you've had in supporting that. And speaking of support, I'm going to turn it over quickly to Andrew.
So hi, everybody. This is a really important moment for our movement to reduce embodied carbon in MEP systems. And there are a number of things that are on the agenda for this initiative and all of the organizations, the companies, and the individuals that are engaged in the movement, including the release, not just the release of the guide, but also an ongoing campaign to get the guide into the hands of practitioners, and then to begin to track the difference that it can make in the way that people actually design systems and build systems. And then the pilot project that is ongoing, and we'll be seeing a lot of results from that over the next few months. And in the course of the development of the initiative, we've also, as you'll hear a little bit later, developed a strategic partnership with Architecture 2030, which will be providing financial fiduciary services and helping us to receive donations and so on. So we want to, first of all, take into account and acknowledge a very few key organizations and individuals, including Rob and Jackie Boland, Christy Walson, and another person who's asked to remain not anonymous, as well as two companies that have stepped forward to provide the very first money that will be able to apply to these important new challenges. And along with acknowledging our first donors, also we want to announce that that we've decided to create a sponsor recognition program. And the key to all of this is that the way that funding and support and resources will come to the movement is from participants in the movement. As I think we all know, there's the challenges for nonprofit organizations and nonprofit initiatives are serious and complex right now in the world, and we already know that it's going to be very difficult to fund the essential work of this initiative merely by trying to apply for foundation grants or certainly for government grants from certain sources. And so we're going to be relying on the companies that have endorsed the initiative, that have signed the MEP 2040 challenge, have made commitments, and then are the employers and the houses for people who are actually practitioners. And so we'd like to make a call for everybody who's on this call. Overwhelmingly, you work for MEP design firms. And we'd like to ask all of you to go back to your companies and make a proposal that your company should be engaged with the movement in a serious way. And an important way to do that is by becoming one of the founding sponsors for the organization or for the initiative. So within the next few days, we'll be sending out an email to everybody on our list with more information about this sponsor recognition program and exactly what we're proposing that MEP 2040 as a movement and as a program and as a set of educational resources is able to do over the next year. So thank you very much for being here today, and we look forward to partnering with all of you in the future.
Thanks, Andrew. Now we'll move into talking about the beginner's guide. It's finally released, and we're so excited and actually proud to be a co-author of that guide with Carbon Leadership Forum. And we have Aurora Jensen here today, who is a senior policy researcher for Carbon Leadership Forum and did so much work and co-authorship as a part of this guide. I was personally very excited to work with Aurora again, as we used to be co-workers at Bureau Happold. And it's just been a whirlwind and pleasure to be able to bring this resource to the market for all of you. And also the findings that we've had so far as part of the guide and the pilot are just so exciting that we couldn't wait to share this with all of you. So if you go to our website, mep2040.org/guide, you will find the guide. But we just can't say enough actually good things about all of the work that went into this from all of the authors of the guide. Or I don't know if you want to add anything from CLF's perspective.
Yeah, sure. So I imagine many in this group are familiar with CLF, but we are a nonprofit organization dedicated to reducing the embodied carbon in buildings and infrastructure. And as you can imagine, we see MEP as a critical piece to that puzzle. So we were just really excited to get the chance to work with Kaylee and others at MEP 2040 to help refine this guide and weigh in on some of the methods that are in here, some of the data sources that are used, and just are really excited to see this resource out in the world.
Great. We've had over 400 downloads of the guide so far. It was 405 when I checked this morning, but it's funny because every time we're Andrew's like, you need to update the slide. It's gone up by 50 people. So we're seeing
we're up within the last minute. We just went to 413 downloads.
Oh, wonderful. yeah, so it's been very well received so far. If you haven't seen the guide on LinkedIn yet, not only did we publish the guide, there are also a bunch of supplementary resources that we provided in terms of data entry templates that have all of those scaling factors for you for different life cycle assessment stages. But we really tried to cater to not just MEP engineers as an audience, but also LCA practitioners, architects, contractors, people in construction management, designers of all types, because MEP does often have an influence with and through other discipline trades. So really trying to give is the best distilled guidance that we could throughout each of the sections. So if we just talk about the guide at a high level, looking at the table of contents and what was in there, there really are so many sections that have richness to them, but really within the first section, that is the meat of the guide in terms of the takeoffs. How and what should you actually be measuring within MEP systems? And we really tried to focus on the Pareto principle of the things that we thought would give us 80% of the result in terms of the embodied carbon when we were looking at takeoffs. So when it comes to things like ducts and pipes, we didn't focus on fittings. We didn't focus on accessories because figuring that those would be proportional and trying to just get this skill set built into the AEC industry as a whole. We also have their beyond the gate section. So everything beyond initial product creation, so transport through to end of life of those materials, as well as a big focus on uncertainty. We've also got a full scale case study. We collaborated with University of Illinois Urbana Champaign, Wymer Hall, and you're able to see the result of that particular project. We know that's one project of the thousands of projects in the built environment that have MEP systems. So please take it that way in terms of it being a singular example, but it just goes to show the great impact that a single building can have and doing that in a really detailed way, as well as structuring calls to action for all those different groups. So like I said, the piping takeoffs section or the takeoff section in general, you've got a lot of material in there that will give you really like the how you go about those, as well as in the A4 through C section. Looking at the A1 to A3 section in particular, not only did we tell you what mattered, what moved the needle, right? So things like whether or not you may have fire protection systems modeled. Half of the buildings in the US don't actually have any branch piping modeled for their fire protection systems. That's a lot of piping that might be missing. Giving you those kinds of tips and tricks throughout here just to say, flag to you, this might not be there, but it still matters and you need to take note of whether or not it was there. And then also giving you an idea of what materials you may see on a project. If you're not coming from the MEP background as an LCA practitioner, you may have no idea what types of pipes or ducts to use for domestic cold water, domestic hot water versus waste systems. They tend to use different materials. So giving you an idea of what that looks like was really important to us, as well as telling you exactly how to input some of the formulas into Revit to get the weight-based takeoffs, because you need to build that skill as well as the embodied carbon measurement. Getting weight takeoffs is really key. And then also thinking about the richness of some of these categories with the EPDs or lack thereof, trying to give you an idea of what the embodied carbon of different materials is with the limited information that we do have. So providing sample figures, references to EPDs where we felt that it might be difficult for people to find those references elsewhere. So that really is the kind of broad brush look at A1 to A3. There's also a great workflow. Actually, Aurora, if you want to speak to the workflow that we proposed for that section in terms of LOD, things like that.
Yeah, sure. You can see it kind of poking through in the back row of the page that Kaylee has pulled up here. But really, that's meant to give users a way of walking through takeoffs, what unit you want to be using, encouraging people to always be calculating in mass or in weight, because it becomes useful to you in A4 through the end of life to have mass available. And that page is sort of an orientation that we really encourage people start with before they make their way through the detailed takeoff pages.
Yeah, agreed. Also noting that at earlier levels of development for MEP, so during schematic design, for example, that is not the time to do an MEP takeoff. And anyone who does MEP engineering would know you'd get very little information at that stage of design. So just taking note of important things like LD 200 being kind of the minimum viable amount of information you'd want to start working with. Or if you want to speak to A4.
Yeah, sure. So I would say our goal for this section of the guide from A4 through C was to rely on existing guidance, existing methods, and repurpose them, reinterpret them, and help the audience understand them in the context of MEP. And we reference multiple sources in this section. We reference RICS, the common guide from SIPC, as well as ASHRAE 240P's draft standard. And in most cases, I would say the ASHRAE 240P is the most prominent, and that's the methods we lean into the most in this guide. And that guide is a draft. So we do want to emphasize that it's possible some of these methods would be updated at that point, kind of to Kim's point in the chat here that this is a living document, and we are trying to keep up to date and aligned with the way that the rest of the industry is working through these methods. Some of the highlights of this section are B1 and B6 because both refrigerants that shows up in B1 in a whole life carbon story and operational carbon that's showing up in B6 are really critical components to the whole life carbon story and interact so closely, of course, because they're generally showing up in our MEP systems design. So we think these sections are really critical and are trying to convey clear methodology based on that ASHRAE 240P guidance that currently exists. Some of the other efforts I want to commend MEP 2040 on are they really worked with some of the folks in this room and in the wider community of contractors and manufacturers that they have relationships with to fill out some of the assumptions that make it challenging to use existing guidance for MEP. So for example, mapping how you might use the transit factors from 240P and how you might use those for MEP. As well as looking at maintenance and repair factors for MEP. So they've really tried to take existing guidance and connect it to MEP use cases.
Perfect. Yeah, in this section, we also made sure to give note of the actual calculation we would be using so that we're not left guessing what that calc is. Things like A4 take mass into account, like we were referring to during the kind of takeoffs portion, giving transport factors and all factors for A4 through C in terms of every MEP category, not skipping anything that we cover during the takeoffs portion so that you know exactly which factor to assume there, and also leaving it up to you. If you know better, then you could change the value. You know you got your pumps from Europe, you could change the value for that. But giving you an idea of where the provenance of those individual numbers came from. Like Aurora said, oftentimes it was from 240P in that kind of US-based context. Uncertainty. I know, Aurora, you were very excited about seeing this calculation broken down, in particular for MEP. So because we don't have much in terms of EPDs, although there are thousands at this point, some categories are more well filled up than others in terms of the number of EPDs. So a methodology within LCA practice that we really leaned into was uncertainty. What were you missing at the individual carbon data level? How geographically specific or similar was it to where you were? How similar was the technology? Is the EPD out of date? Really breaking down how that calculation works because, and we also show that in the Wymer Hall case study, it matters, right? It's usually recommended that the top 10 most carbon intensive categories or products have uncertainty calculations against them. It really was illuminating in terms of if you had to use a TM65 method, how similar was that or compared to perfect data, and being able to display how we perform those calculations because we wanted to kind of stop that chicken and egg conversation. Oh, we don't have enough EPDs. We can't perform the LCA. We can. We just need to lean into uncertainty a bit more.
Yeah. The other comment I'll make on this section is there's a piece called reporting results. And I think in this section, it starts to talk about normalization. So how you would take your total global warming potential estimated based on this guide and divide it by some kind of meaningful metric. And for most embodied carbon analysis performed today, we often see that being the gross floor area of the project. And in this guide, we encourage people to continue to use that gross floor area metric. However, we also speculate a bit on specific alternatives that might be useful and informative for MEP designers specifically. For example, megawatt of power consumption in particular building types, or cooling ton, so GWP per cooling ton. And I think that's a piece that we're interested in this whole group also providing feedback on and thinking through as you work through these analyses on your projects, is what kinds of units are technical and quantitative in such a way that they can provide us insight on the design of subsystems within the larger MEP framework.
And then the case study for Wymer Hall, a really key piece of this was, how do we define our buildings or projects so that they're comparable with each other, right? Because you wouldn't compare a library to a data center necessarily. And wanting to take into account all of those properties, and we had a huge exercise with this at the ECHO project. CLF just went through their V2 benchmark. Check out that research that was just released as well. But what pieces of the building's design or the MEP systems design did we think would be those differentiators for buildings, and saying, please don't try to compare these buildings of certain topologies or within certain climate zones, or maybe just different U values for the envelope, the window to wall ratio is so different, they shouldn't be compared. Really wanting to make that clear in terms of what we wanted to keep track of, and trying to find a sweet spot of a minimum viable product that we felt would get us these kind of comparable, rich results. We also provided the quantity takeoff for you so that you could see the mass of all of those different categories that fell within the MEP systems. It was around 400,000 kilograms for the MEP systems. This is compared to 1.2 million kilograms for the structural system. So high weight for the structural systems, but the amount of embodied carbon for them is less because it's concrete for this building. In general, if we were to come up with the kind of sum product for the GWP for structures against the kilograms. But it's just an interesting kind of metric to think about in terms of the weight of all those largely metallic components. We also broke down the results for you across categories, across disciplines, so that if you're having those conversations with a mechanical engineer, fire protection engineer, plumbing engineer, electrical engineer, you know what's moving the needle within those individual scopes. So everyone kind of being able to look at their own responsibility for those systems. We've displayed graphs in the past of all of the different consultants we took into account here, lighting, vertical transportation, right? They're all part of this puzzle. And then also being able to look at how the MEP systems are influencing the whole life carbon over time, taking into account not only day one embodied carbon, but also all those other impacts, A4 and beyond, the replacements of those systems, and then finally the operational emissions also being taken into account, just to get that kind of rounded full life picture. Or anything you wanted to add here on the case study?
I think what's really exciting here is the level of detail that's presented in the case study. You can really see, which piping types are contributing to the total, what subsystems are contributing, how much are chillers showing up, or the geothermal system in this building. And there's just a lot of richness there that, I'm excited to see more projects come in and also share this level of detail, but I think it sets a high bar for how much information we can present and learn from in these case studies. All right. So calls to action. The guide closes by offering all kinds of different parties in this ecosystem methods to get involved and suggestions on what those action items look like. So you can see the page in the middle describes action items for manufacturers, for designers, for owners, and for contractors. There's also pages that look at certification and policy applications. And you can see on the far right, we're mapping this roadmap to 2040 that we think is going to help us all together as a community create this movement to decarbonize MEP systems, specifically the embodied carbon of MEP systems. And as I was also part of the benchmark team that recently delivered the CLF benchmarks report that came out last week. I want to share that we would be really excited to see that group of 300 buildings that were part of the benchmarks report consider this methodology and explore the impact of MEP systems, because having that whole life carbon picture, both what we presented in the benchmarks report, as well as the estimates of operational carbon, refrigerants, and MEP embodied carbon shown in this guide, would help us connect the dots as an industry and get that holistic picture that we're currently missing. So call to action specifically to our CLF community to help us fill in some of this data with those benchmarks and projects that already exist. But really excited to have these pages become a shareable resource and help people explain what different parties in this community can do to move the conversation forward.
Thanks, Laura. And then as a kind of summation of the guide, we really just want to thank all of the authors, the contributors, the reviewers. We had so many people involved with this project. Like Aurora mentioned, working with people like Turner, Joel from Turner in particular was extremely helpful in terms of giving us some of that clarity around categories like A5 and C, end of life, what those impacts are, what we can quantify today, what we need to still do more research on, and really giving a kind of framework around where we should be measuring and what more realistic values might be based on Turner's experience. Also working with manufacturing partners to figure out how often things are maintained. All of these pieces help to kind of bring together different areas of expertise, even just along MEP, FP, LV, right? All of those consultants need to have a kind of say in terms of what their individual subject matter expertise is. And it really is just a great example of collaboration across our industry and even just the small portion of the industry. So big thanks to all of you. All right. Now we'll move into the whole life carbon pilot. So we started this pilot back in February, knowing that the guide was going to be released soon and actually trying to get some feedback on individual sections. That actually brought to light all of the individual Revit formula sections that you'll find there for takeoffs in the BIM environment, because the teams wanted that, needed that as part of their process. So it was great feedback for us to receive during those kind of early days of the pilot. We have about 40 weekly participants, which is excellent to have all those different voices kind of feeding in on their experience. Really great to get some electrical feedback that we've had during those sessions on different takeoff processes or methodologies and kind of seeing alignment across the industry. So really thankful for all the people who are a part of this pilot. Like I said, it started back in February where we were talking about how these buildings relate to each other. And we've actually had some great conversations around specific topologies like airports and how they may be functionally equivalent, how we want to perform those takeoffs to make all of the airport studies comparable to each other. So we're looking forward to those conversations. We've finished the takeoffs portion. We wrapped up with geothermal last week and then moved into A4 to A5 just yesterday, actually. So we're looking forward to getting through the calcs. We're going to have a midterm kind of submission of data for everyone's takeoffs, just to spot check everything. But then we're hoping to get some exciting benchmarking results out of this for the topologies that all of us are studying. We're following the guide completely, following things like the project definition and how we define buildings versus each other. And we got some initial feedback on that, which is excellent. And then also using the data entry template that you can find on our resources page for the guide in the downloads, which just gives you all those kind of basis of factors for things like A4, A5. Again, you can change those factors if you have things that are more project specific, but giving you a kind of starting point and being able to multiply those factors out. But these are the project types that we're studying. So we've got a number of education buildings. I've actually just finished my portion with an education building, and I'm very excited because it's very comparable to Wymer Hall and being able to compare those buildings to each other. Some exciting insights coming out there already. And then we've got 7 offices, 3 airports, labs, hospitals, residential buildings, warehouses, data center, public assembly and lodging. So big spread of different building types, and hopefully we'll get some lessons learned around each of those that we'll be able to share with all of you in the future. You could also follow along with the pilot if you would like. So we've got all of the sessions that we've had with the pilot so far available on YouTube at the MEP 2040 resources channel. We post them after we have the initial session, not the Q&A, but the first session with the group. So feel free to check that out if you wanted more of a deep dive on how to execute each portion of the guide. Each of those YouTube videos should give you a pretty nice tutorial along with some commentary from the group as we've gone along with the pilot. All right. And with that, we'll be moving on to our panel discussion with Brian Johnson from HOK, who is part of the guide creation, very focused on mechanical equipment as part of the guide creation, is also part of the pilot project. We've also got other Kaylee Levine. Always nice to have two Kayleys in the room during the pilot. From IMEG working with us on the pilot, AJ Hodge from Smith Group was working on the pilot, Aurora, who we just spoke with from CLF, and then Wyatt Ross from CMTA, who is a big part of the guide, and then also the pilot. Now I think you've got actually several projects from CMTA as part of the pilot. So thank you all as panelists for joining us here today. We had some questions for you all on a few different topics. Feel free to put some questions that you've got as an audience in the chat, and we can answer those as we go along. But the first question to all of the panelists would be, in terms of establishing Revit best practice, what's the role of that in terms of how you've gone about the pilot? Have you seen any pivots you might need to make as a firm in terms of how you set up projects, or the types of insights you might need to get out of your models that you didn't previously? What has everyone's experience been with that?
So I can speak from Smith Group's side, working in trying to get our model up to speed to be able to actually take the takeoffs that we need. We are working on a project called Davy Tree, and we are working in a model that is LOD 200. So we can understand for everyone involved in the pilot that an LOD 200 is not going to be an actual coordination model. There's going to be things that are missed. We have found, thankfully, that even working off of a design model, working off of one that is not upgraded for this pilot, we were still able to get ductwork, piping, and equipment takeoffs to a degree that we would say at this stage is sufficient. So we can comfort the team largely that having to include additional parameterization has not so far been a demand. We have not had a need to enhance models beyond what we do at a design level. There have been gaps. There have been elements that, as you mentioned earlier, Kaylee, when we were working in fire protection systems, a lot of times we just have those boxes that just note, put this much fire protection in the area. On the lighting and the electrical, we understand for everyone that oftentimes I'm a mechanical engineer, and I do wish sometimes to be an electrical engineer and get to write a takeoff all the way back from my piece of electrical equipment back to the panel. We have to draw our ducts and pipes, so electrically there are physical gaps often in what is in the model, but Revit has excellent tools to be able to estimate the wires that go from panels to equipment. So largely, we have been able to take an LOD 200 model and not have to go to 300, 350 to do takeoffs. We've been able to make it work.
Yeah, I would say similarly. So we have 3 projects that we're doing as part of the case study, and they vary widely in terms of level of development. There's also some projects had certain scope that was under delegated design. So you're bringing in different MEP engineers and designers, their model into a collaborative linked model. And so, even across the different disciplines, there's different levels of quality and detail or available information within the Revit model. But I would say, similar to Alex's point, I don't think we've had any issues really getting to an estimate, even at a LOD 200. It's just been a little bit different process and a little bit more nuanced approach on each of those three case studies. And things that we've learned is that there's certainly room for efficiency improvements across how we're doing that. So a lot of what you'll see in the guide is the ability to standardize schedules and incorporate those into templates. There's other things that you're going to think through how we approach a little bit better, how we represent and indicate parameters for materiality for especially piping and ductwork or insulation or whatever it may be. Just making sure that that's a readily available parameter in the families that everyone is using. It may not get used every time, but just to have the ability to track that. And if a project we know is going to be doing embodied carbon and an LCA for MEP, that the practitioners on that project have the ability to track that pretty easily within Revit. So that's kind of our focus right now.
There was a question in the chat about Revit models that are used solely for clash detection rather than quantity takeoffs. And what do you all feel that gaps might be there? If I can think of a couple, but I'm sure you all can too, in terms of the information you would be missing for being able to perform these takeoffs.
So we have largely found that the materiality in our models and the system designations have been adequate to be able to get the information we need for the takeoffs. When working in a Revisto or other contractor-focused model, that's likely the one gap that is the major concern, is having system designations and materiality properly aligned and parameterized. It doesn't mean that won't happen. A lot of times the systems are pretty well developed, but a good amount of the guide is built around knowing exactly when you pull something from a pipe or duct, knowing what it serves and what it is, so that you're able to calculate whether it's stainless steel or copper type L or G90 or a Schedule 40 pipe. So there's been a lot of work outside of the model to be able to massage that data to bring it in, but largely that is the biggest gap. And unfortunately, we have not yet done that kind of design in our own pilot, but other pilot team members may have worked to some degree in those LOD 350 level designs.
I think something we were trying to achieve is comparability, right? And we're saying LD 100 is too sparse in terms of information. 200, 300, probably okay. 350, even better. But as part of the guide, we also wanted to say the things that were excluded because they are typically not modeled, which is what Jamie's point is in the chat about hangers and dunnage being modeled in some cases when you get up to LOD 350. But we wanted a kind of standard of care of what is measured. So actually not measuring the hangers because you will have them on every project, and kind of being able to say we're not taking that into account because it's largely not there as a skill for us as an industry. Also, I think we had a very discrete conversation about structural support and said that is in their scope because it's typically something like a concrete pad. So trying to eliminate that from the MEP scope overall, but it was a consideration for us. Next question we had, what is your opinion about the state of the MEP environmental product declaration data that's available today, given our experience procuring those items?
It's enough to be dangerous, right? So I think, we certainly need more EPDs across the industry. We're using a lot of proxy data currently, as you'll see as you read through the guide. New tools becoming available, the MEP LCA tool in one click and others, kind of consolidating those data sets is really helpful. But we are still missing a lot of information. And I think we see TM65 North American addendum coming out as a option to get some even more proxy data, but we really need mass adoption from manufacturers, publishing EPDs, kind of focusing on the most commonly specified equipment within certain equipment categories. And that would go a long way to helping us improve and remove some of the uncertainty, because I think a lot of what we're trying to do is compare across system types or compare, come up with rules of thumb or come up with best practices for how we reduce embodied carbon. Right now, it's kind of just building up the data set to have a better understanding of what we don't know. But until we have a lot of EPDs in a robust library, it's going to be hard with a ton of certainty to select between different products or different system types and know for certain that you're reducing embodied carbon across MEP systems.
Yeah, I would agree with that. I would say it's a really spotty landscape. Some portions of MEP systems are well covered and others have almost no data at all. And we address that throughout the guide, giving direction on what criteria should you look for trying to match in an EPD, or how might you scale an EPD that it has similar components to what you're trying to model, but isn't a perfect match. And what we really want to say with this guide is that we do think there's enough data to get started, and that we'll learn something from applying this data and working through both the takeoffs process and the application of EPDs. Because as this community grows and more pilot studies are undertaken, those requests get communicated to manufacturers, to building owners, and we start to see the market move. And I think even in the past 5 years, we've seen a huge number of additional EPDs and other data sources for MEP come online. And we expect that to continue and be bolstered by efforts like this. I'll also say the uncertainty piece of the guide is meant to help fill some of that proxy data gap and help address and describe really the delta between the data you're using and what a perfect data set might look like.
And one of my biggest takeaways from the pilot project, just the state of the data out there. It's really encouraging that what's out there exists, and we can get these kind of ballpark estimates of the embodied carbon.
Haley, your voice is very, very, very small. Can you
Sorry about
increase
that.
your volume a bit?
Change my speakers.
That's
Is
better.
that better?
I think that's better.
Okay, thanks. So it's been very illuminating to me about the state of the data for MEP. It's been encouraging that we have what's out there to be able to just get these estimates. But the fact that all of our data is using either European data or LCA generic data, we're not using, I don't think, any specific data to our project, has been really eye-opening and creating kind of a sense of urgency that goes along with our requests for EPDs. Something that came out of our experience is just making more requests because we found those gaps. Can say specifically, we're trying to do an LCA with your product. We can't do that right now. Can you please provide this data? Just gives us another opportunity to make that request. And will help in the future for actual comparisons, because right now it would be difficult to do comparisons with the kind of more generic data that we're using.
Yeah, it seems at this point we're able to do kind of high level quantitative comparisons rather than the specifics of an individual product being compared. Maybe something like chillers is a bit more full in terms of the number of EPDs that are available. But something that I've learned from Josh Jacobs and Shannon Sajak is that using TM65 is a great way to get your foot in the door with manufacturers in terms of having them start to ask those questions to the finance department, typically, from what I understand, of where they're sourcing different component parts from, how much of each raw ingredient's there, so that you're kind of beginning the process of actual EPD creation by forming those connections internal to certain companies. And I think that it's a nice proxy when you don't have the kind of raw material data available to you in general, but being able to open that door so you start to collect information and get the manufacturer moving, especially some of those manufacturers in very large product catalogs. It'd be great to see those doors opened because we're some small parts in MEP. How are you balancing the technical rigor suggested within the guide with the practical constraints and timelines of a project? Is that something any of you have thought about?
I think at HOK, at least, we're trying to draw a lot from what we've set up with SE 2050 and the processes and workflows we have there, and bring that into the MEP 2040, and the embodied carbon of MEP systems takeoffs. While this effort has been a bigger lift the first time around, establishing those templates that are just going to live in the Revit schedules from now until we update them next time, to have that data available at our fingertips without going through all the effort the first time, really helps to gather the takeoffs, which might seem daunting like the first time you go at it, but once those processes are established, really it's just pulling in data from the schedules, and it's a much lighter lift going forward to help us get those data points at different parts of the project design. It was really kind of the eye-opening thing that put us to ease that this is possible and doable in the timeline of a traditional MEP design. I I think once that gets going, we'll be able to look at kind of the outputs from the different building typologies and compare and contrast and really add to that benchmark data set and make some meaningful um, design decisions from the data, hopefully. But for now, it's we're getting started, we're getting going, and hopefully we're set up to move in the future.
Great.
Yeah.
What? Oh, sorry. Go ahead.
Oh, no, you're good. I was just going to say I agree with Brian. I think where we're at, most of these are retroactive studies at this point. So we're going back to previously designed projects. And I think phase one for integrating this into design is coming up with just heuristics that we kind of know what's best practice. Like focus on doing these things if you want to make an impact on reducing embodied carbon. And then step two, talking about how we're going to improve Revit standardization is just improving the efficiency so that we can start to implement this within a kind of a realistic design schedule. So that's kind of our approach right now.
Have any of you had unexpected insights so far? We haven't completed the pilot studies yet. Or Wyatt, I know you've done at least one that you presented at Greenfield, but what kinds of insights are you seeing so far, if any?
Yeah, I think some of the big things, one of the things that we were really focused on was related to geothermal applications because we've just done so much geothermal and understanding what the embodied carbon impact of that is. So, one of the things that we are still hoping to understand is how that compares to other electrification options because we're seeing, operational emissions still large and matter significantly, especially when you're making comparisons between on-site combustion versus fully electrified systems. But once you get to those fully electrified systems, then the embodied carbon discussion becomes really interesting of comparing, different hybrid approaches or geothermal versus air source heat pumps, et cetera. And so we've been pleasantly surprised that geothermal isn't quite as bad as we expected it to be, but there's still a lot of outstanding information that's needed, a more robust data set on the drilling and the A5 implications of geothermal, especially. So that's kind of an area that we're focused in on right now.
I've been getting some insights on just the amount of effort for doing this assessment, and we're trying to think about what are the lowest effort areas that have the highest impact for going forward with building this out into other projects. So something like lighting, I would consider was very high effort to add to the assessment. Something like elevators, that was my favorite one to do. It was so simple and easy and had a very high impact. So yeah, just learning more about where we can most efficiently focus our efforts to get the biggest hitters for carbon.
For our pilot study, one of maybe not the most unexpected impacts, but interesting developments is finding the degree to which MEP equipment has often been driving the embodied carbon of systems as opposed to distribution systems. Our system is a air source heat pump condenser build. So the distribution is primarily piping to terminal units that have their own ductwork. And even in that case, we're finding that the ductwork still is significantly more than mechanical piping specifically. Overall piping is double to triple the load. But MEP equipment is a strong driver in those kinds of disconnected piping hydronic systems as opposed to centralized forced air systems. So that development of the data does give us some insight that as we go from the phase of measuring and trying to get into the managing, that there could be opportunities at the equipment level primarily to try and reduce overall embodied carbon, whether it's more thermal energy storage or other methods to try and reduce the peak load size of our plants.
I'm really interested to see how the climate zones have a impact on where the results land. I've got a project out here on the West Coast in the Bay Area where we don't have weather like a lot of the rest of the projects do. So where we don't have perimeter heating systems, for example, what does the embodied carbon difference of that look like, and how can we make some comparative analysis to, beefing up the envelope as opposed to, possibly getting rid of a whole MEP system? And is there some inferences we can make with that? So hopefully we can look at those kind of things coming out of the study with more data.
I'd say the other thing that really stands out or stood out dramatically the first time we did this was just the replacement rates and how that drives whole life emissions, and thinking about, how do we design MEP systems for longevity? How do we avoid planned obsolescence? How do you make them adaptable depending on the building typology? Because so much of the embodied carbon lives in that replacement rate. So even thinking about how we take that to a kind of a design philosophy, or where do you put MEP equipment? How is it outside? Is it indoors? How does that impact life cycle or service replacement rates? So that's just been an interesting kind of thought process for us to go through as well.
Love all of those insights. How granular do we all feel the benchmarking data will need to be? We started to touch that in terms of climate zone, things like that, potentially being really critical. But again, we haven't seen the data, so we're not sure. But in terms of the comparison of like with like, what do we think will matter the most? What will matter the least? I know I wish we did a lot more digging in on B6 in terms of end uses, because if you get two buildings that are very similar but look very different actually in terms of results, knowing things like COP average could be really helpful. What do we think about the evolution of that kind of benchmarking phase of where we'll get to?
I think connecting this to the benchmarking work that's been going on at CLF, the granularity in the metadata you collect on the project is everything in terms of what questions we can ask with that data set. And we've really tried to be intentional with this guide to collect definitions for the heating and cooling primary systems. What are the other specialty systems that are present in the building? As I kind of referenced earlier, what are some of the technical criteria around the loads of what those systems can can serve? And I think in collecting those kinds of technical details, we will ideally be able to unpack the trends in this data set by climate zone, by system type, by how the heating and cooling systems operate together or as completely distinct systems. That will give us tremendous insight. Although, of course, the number of projects has to rise with that level of detail in order to have any meaningful sample sizes within those subgroups. But anyways, I don't know that we know what those outcomes look like yet, but I think the structure we've set up is really promising to help support some really detailed benchmarking insights to an unprecedented degree.
We'll move on to the next question. We talked about hotspots that appear. It sounds like equipment largely compared, well, vertical transportation. Kaylee also mentioned that one, which is really good. But also in terms of process loads, a very big increase on projects. Are you thinking that we're finding insights through the pilot that will reshape the way that we end up collecting data in the future for something like a V2 version of the guide? Is that something that you all could share some insight on the conversations we're having as part of the pilot group? Thinking, Brian, of the airport specific conversations we've been having around the specifics of modeling techniques for certain topologies causes these kind of differentiations. Could you speak to that a bit?
Yeah, I think for airports, the comparative metrics around kg CO2 per square foot are nice, but where you've got specific metrics that might make more sense of passenger throughput per year for a stadium, the number of seats, or the annual spectator, expected occupancies, we can get a little bit more granular to do a better comparative analysis of that. Some airports are massive and spacious and have a ton of retail in them. Other ones are tiny and are very bare bones, and they're focused on just getting people to the airplanes. So things like that might differentiate um, a small airport from a big airport on, a centralized system versus a package system around some of the aircraft equipment. I know we've got differences coming out of the three airports that are in the study. So, just seeing what comes out of there, it's hard to speculate what the data is going to show, but I know we're going to want to compare metrics around like passenger throughput is going to have a big differentiation between the facilities, which I know are all very different sizes and scales.
And to bolster Brian's earlier point as well about how that impacts the way we benchmark and estimate different buildings. I'm in Boston. I'm not in the Bay Area. Our winters go to 0 degrees. Our summers go in the 90s. So there is a benchmarking that affects especially the central systems that is going to be important for giving teams estimations at the SD level of future projects of where they think the process is going to go. So there is going to be, in my mind, some level of a need to focus on a 3-variable path where we have the weather data as number 1, the typology is number 2, where we're looking at whether it's an outpatient or inpatient medical facility or a laboratory or an open office or a training building. And then number 3 is going to be then trying to give people benchmarking based on system types. As I mentioned earlier, we're going to have, if you have a forced air variable volume mechanical system, you're going to have a very heavy load on ductwork in your embodied carbon analysis. But if you have a central condenser water loop system, it's going to invert to a good degree towards a piping demand in the space. So the more we can get those 3 variables benchmarked, the better we're going to be able to help people in the future when they're in that SD phase and they don't have even an LOD 100 model to be able to get a sense of what those typologies are going to look like, at least theoretically.
Makes a lot of sense. Thanks, AJ. All right, any other thoughts from the panelists before we move to the next section?
The last thing I would say is just that I think at the end of the day, right now, where we're at is less, right? So reduce loads, that's smaller MEP systems. Smaller MEP systems means smaller structural systems. Kind of all trickles down from there. Lower refrigerant charge means less leakage. So just kind of prioritizing a lot of what we've been prioritizing as an industry already, which is reducing loads, I think goes a long way to reducing everything else downstream. So.
That's a good point, Wyatt. And there was a question in the chat about some short and long-term solutions for MEP carbon reductions. And what Wyatt said is summarized on the mechanical and electrical equipment embodied carbon insights from the A1 to A3 section. So you'll find these kind of tips and tricks around carbon reduction for every category in that A1 to A3 section of the guide. Speaks to obviously more than just the upfront embodied carbon, but so I suggest going to those pages if you're looking for some more insight. But we're hoping that we get great detail of insight from all these pilot projects and figure out what it is we need to study moving forward to form even, I guess, more insightful outcomes for all of you. And hopefully we'll be able to share those outcomes in the coming months. So thank you to all of the panelists who are here today. And we will move on to the next section. Vince.
Thanks, Kaylee. Really amazing work from everybody, and congratulations to the report being launched. As Vincent Martinez, I'm the CEO of Architecture 2030, and I'd like to talk a little bit about the relationship between MEP 2040 and Architecture 2030 and the updates. If you missed the last webinar, internally it's been called the MEP 2040 initiative has reached its adolescence and is booted out of the house of CLF. That's, of course, not completely accurate, but just to say that CLF has moved on to other deep research pieces, and MEP 2040 has found a great home under the fiscal sponsorship of Architecture 2030 as one of our strategic initiatives. For those of you that don't know us, we're a think tank that has been around for about 20 years, founded by the architect Ed Mazria, who's our founder. If we go to the next slide, please, Kaylee. This relationship was founded due to value alignment. Architecture 2030 as a think tank has always provided free and available resources for moving to decarbonization of the global built environment. This also helps because Architecture 2030 is a 501c3 established organization, so we can receive grants and other types of donations that are tax deductible. Back to Andrew's comment at the beginning of the forum about donating to the MEP 2040 initiative can go through 2030 Inc., our nonprofit, to pass those funds through to moving forward on the engagement and other strategies and research. As part of this process, which is I'm going to spend most of the time talking about today, is a focus on the new governance and leadership structure and participation. We're extremely pleased, of course, that the leadership of the steering committee, who you saw all those lovely faces at the beginning of the forum, have been really guiding this broader industry effort for the last 4 years or so since its inception. And underneath the leadership of Architecture 2030, we're going to be updating the governance structure and leadership structures and engagement structures for this effort. So I'm so glad that we have over 100 people on the call today, because this is our opportunity to tap you in to help build the capacity and resources of the organization and move us forward through our next year. So we're actually opening up a nomination process to find committee members and working group members for a number of different aspects. And I'll go into great detail about this in a minute on each section. But essentially, we are creating a new advisory committee, and that advisory committee will support Architecture 2030 on strategic decisions and fundraising opportunities for the MEP 2040 initiative. So if you're interested in that sort of high level strategy pieces, that would be the group for you. We're going to have reformat a steering committee, which will be made up of the leadership of the different working groups, which we'll discuss in a second. And we'll also have liaisons to the steering committee and from the steering committee. And then we're having 4 particular working groups that were identified by the previous steering committee, and we could expand those over time. These are 1-year terms, essentially task forces or project-based work. Most of the work that came out that you just heard about from the report is from the Data Analysis and Reporting Group, also known as the DAR group. And so that work will continue, including the benchmarking analysis, which is slated up next for the process. We're also going to focus on an industry education group. So this is getting the work of the guide out to the public, like this webinar and others, as well as looking at other resources and compiling for MEP 2040 information, but also broader from the MEP industry. And then the engagement and communications is the work that essentially CLF had been doing through our great leader here, Andrew Himes, is to support these quarterly forums and other types of engagements, including the newsletter. So this is really focused on communications. It also will help answer questions we get about from prospective signatories or current signatories. And so if you're interested in the communication side and engagement side of things, this would be the group for you. And then finally, there's a manufacturing and EPD engagement, and this is really about collecting EPDs, providing information about the templates for how to request those, and looking at other ways to engage the manufacturing industry. So that's the working groups. If we go to the next slide, we're opening up this call for nominations, and we'll put the link into the chat if one of the current steering committee members could include that. We're going to open nominations up today, and they'll go through the month of May. There's a form that we asked you to complete. If you're interested in any of these groups, it'll give you more information about the term and what you're signing up for, whether or not you're interested in being a leadership on the chair of any of these working groups or committees. And then we're going to close that at the end of May. And then the current steering committee will make decisions about those nominations in the month of June, and we'll start this whole process in July. So that's when we'll have start dates on annual and multi-year terms moving forward with this effort. Next slide, please. So again, more on the advisory committee. This is a group that is essentially, the steering committee has been acting as an advisory committee and a steering committee. And so we're going to be breaking those 2 pieces off. There will be some liaisoning to make sure that the steering committee and the working groups can implement the vision and strategy of the advisory committee. But this is going to be helping focus on our advocacy work, broader engagement and partnership development that Architecture 2030 will do for the MEP 2040 initiative, as well as our fundraising approaches and setting a budget for the initiative. Two members of this advisory committee will work with the steering committee to make sure that there's alignment. So this is we're going to have 3-year terms, but as we're just getting started, we need to stagger terms. So you can, if you're interested, sign up for a 1-year term or a 2-year term for the advisory committee. But after this year, there will be 3-year terms and we'll cycle on and off about a third of the committee. We anticipate that these will be bi-monthly meetings, so every other month they'll meet. So it's about 6 months a year. And again, if you are one of the liaisons to the steering committee, if you're interested in that role, you'll be meeting more regularly. And if you're interested in the chair roles or the vice chair roles, then of course you have a little bit more responsibility to help set up the agendas and the meetings. The next group is the steering committee. And again, this is really about implementing and executing the strategic direction established by the advisory committee, and then leading the working groups and having liaisons with those working groups. This we're looking for as a 2-year commitment. Again, if you're interested in being chair or being one of the liaisons to the advisory committee, then that would have a little bit more responsibilities. But this is also looking at every other month meetings and really helping to drive. This is the workhorse of the MEP 2040 initiative. Kudos to Kaylee, particularly, who's sort of done it all and participated in all of this, but really that's the kind of effort that has been involved in this. But because we're splitting this up into different pieces, this is really just about execution. So next slide, please, Keelan. I'm going to go one by one with the working groups, but it might actually be more helpful if I'll talk about the structure pieces, but if any of the current or what we would call past working group members on these things wanted to say a little bit more about what's been involved and what the work has been to date and what they anticipate, I think that would be really helpful. But these are, again, 1-year term commitments. So if you're interested, again, in getting down into the details, this is the depth of the work. And if this focus is continuing the work that the majority of the MEP 2040 initiative has been doing through data analysis and reporting. And again, the term limit is a year, and the established meeting schedule will be determined after the group is figured out. So we don't really know exactly how often you'll have to meet. It sort of determines on what you'll be working on. But Kaylee, you led this if you want to share a little color to it.
Sure. Data analysis reporting, the DARS, as we've lovingly referred to ourselves over the years, is our most active working group at present. We've had over, I think, 100 different members. We have a steady group of about 40 people who meet together. This is where the guide came from. It was a bunch of DAR group members who stepped up to take part in that guide creation. And then the Whole Life Carbon pilot has been the evolution, actually, of the DAR group. But really, we're looking for that group to continue to evolve with those more strategic initiatives in terms of data collection and benchmarking and coming up with a strategic direction and pieces that the education working group really should be kind of moving forward with. So if a V2 of the guide was created, if another pilot study came out, those would be activities that the DARs would be doing.
If you're really into the data and all the LCAs, this is the group for you. Next up, please, is the industry education working group. Again, all working groups are 1-year commitments, and the cadence will be established by the working group chairs. Kim Shin, if you wouldn't mind giving a little bit color to this, this was your brainchild, and talking about what you're hoping that this group will accomplish.
It's really to sort of bring the work of the data and resources, data analysis and reporting group sort of to our membership and to the industry. This is where the tools and the studies get packaged into webinars, study guides, white papers, the kinds of things that you can hand to one of your design teams, for instance, to say, okay, you tell me I'm supposed to figure out what the embodied carbon is for this project and how we can reduce it. I've never seen anything like that. I've never had to do that before. Can you teach me? So this is the group that's really kind of, like I said, going to be the link between the industry and putting the tools and resources that we develop out of the DARs to work. It's also where we hope to create a library of presentations. So if, for instance, your local ASHRAE chapter or your local AIA COAT group wants to get some information about MEP 2040 and what we're doing and how we're doing it and a specific tool or resource, there would be a consistent messaging platform that that you could rely on to draw from out of this industry education's product library.
Thanks, Kim. So if you're well organized and you also know how to drink from a fire hose of information that comes out, this is the group for you. Next up is the engagement communications group. And this was, again, mostly the work that has been done by CLF over the last number of years that we need to find additional support and capacity to handle. And we think this should also be done in a curated and collaborative format. So the more folks that are helping to help direct the messaging and communications of MEP 2040 to the signatory group and the public, this is the group for you. So Andrew, if you mind saying a few words.
Yeah, I'll just add, so the focus that I want to put on this group is that first sentence of description. We're focused on the mission of MEP 2040 to build a movement. And building a movement is obviously a collaborative and collective effort. So in order for MEP 2040 to succeed, we need a lot of people joining in to spread the word and talk about it and think about how to reach out to more and more organizations and individuals to participate in MEP 2040. It's a collective effort. It's not just an effort by a few people on a steering committee or by a couple of nonprofit organizations. It's a movement, and it requires hundreds of individuals and organizations to be part of it. So engagement and communications is about it's about hosting the quarterly forums that we've been having now for 3 years. It's about communicating through the LinkedIn page for MEP 2040, as well as through the idea that we have of starting a new monthly newsletter to go out to now close to 1,200 people on the mailing list for MEP 2040. And so we want to really encourage. It would be great if we could get even between 5 and 10 people from this group here on this call to say, yeah, I want to be part of helping to build that movement. And I've been part of this effort since the beginning, but I'm really looking forward to having a number of partners and collaborators that I can be part of a team with. And Rob Bolin has also been part of this since the beginning. We're looking for partners and advocates and allies.
Thanks, Andrew. So if you're a communicator and you're social media savvy and we're helping distill information in newsletters and helping organize these kind of calls, this is the group for you. And then finally, the last group is the manufacturing EPD engagement group. And I don't believe that we have any of the original developers of this, but this group had started a number of years ago and then dropped off a little bit, but it helped develop templates for you all to share with manufacturers about requesting EPDs. That was one of its key pieces, but it also could involve other aspects of how does this become more standardized in codes and other standards, big S standards like 240p, for example, or in small S standards or other types of rating systems. So this is really about collecting the information that we need from those in the material supply chain. Kaylee, did you have anything else that would be relevant to add for this group, since I know we don't have some of the leaders of it on the call?
Adam might be on. I'm not sure if he's able to speak to some of the previous activities that have gone on within this group.
Josh is on.
Oh, Josh,
I'm
great.
here.
Oh,
Josh,
hey, Josh.
too. Hey, everyone. Yeah, no, Vince, you did a great job, man.
All right.
Basically, it's trying to get the manufacturers to understand what we're asking for, right? And connect all this great work that you folks are asking for and explain it to them, because there are so many manufacturers that are still like an LC who, an EP what, TM where, lots of acronyms. So basically trying to get them engaged and get feedback from them to this community as well, right? Because not everyone has the time to actually engage directly. So bringing these two groups together, making sure that the data can be available, and then obviously taking information back and bringing it into all of you.
We'd really like to have some manufacturers, not just design people, but manufacturers working in this group.
Yeah.
That's a real key need that we have in memberships of the working groups that we really need to fill out.
Yeah, and one thing there, Kim, is we have certainly we've had a couple that have been very, very active. I know in the chat we've had some back and forth chats about what's available, what's not. Those that have been involved are publishing EPDs now. So I'm not going to say it's a one-to-one correlation, but it's certainly, the data shows that it's that way. I'm sure the DARs would tell me that the data says that that's a one-to-one correlation. It's not bad.
Yeah. Thanks, Josh and Kim. Final slide. So just I see some of the questions in the chat, and I'll be clear. So by nominations here, we are taking self-nominations. So if you know of somebody, please don't sign them up for something without their knowledge. Go ahead and reach out to them. Let them know what the commitment is. Have them complete the form that is linked here at the bottom, and we'll put it into the chat. But we do ask for information about why they want to join the group, what their intention is in joining, and whether or not they'd be interested in a leadership position. So you're in this nomination form is self-nominated, just to be clear. I mean, if somebody needs help and you want to help them self-nominate, you can do that. But this is for those individuals, and it will encompass not just the leaderships or the chairs, but the broader membership of each of the groups and the committees. I'll say that again, this effort is phenomenal, and it has been led by a small handful of individuals and professionals in this industry, many of whom you hear time after time in these forums. But this is a larger collective movement now, and it is opportunity for broader engagement, broader participation, and to highlight your leadership that you have in your own firms or with your own industry organizations. So I highly encourage, this is the time for deep engagement and collaboration. We need new blood, we need new ideas, we need broader and larger capacity, and we want to keep those institutional connections for those that have been leading on this effort for the last 4 years. But really, this is hopefully a time for them to take a little bit of a well-deserved break, share that information, and we can get some new blood and new energy into the space as we move on to the next phase. So please, I highly encourage you to reach out if you have any questions about this, but the volunteer form is listed here at the bottom, mep2040.org/volunteer. And if you have any questions about the term limits and what it means to be a chair or a vice chair, please reach out to any of the current steering committee members. And all of this will get updated in July, and we will have a brand new advisory committee and a brand new steering committee. All of this will be well formalized. So I appreciate all of your attention, and I hope that you'll nominate.
Vince. All right, we'll leave some time for Q&A from all of you. If you want to unmute yourself and ask questions, feel free to do that. Add questions in the chat.
Hating dead air. What's the plan for more people to get involved in working in these groups of LCA studies? I know one of the things that's really been positive about the pilot study group is that there's been a lot of peer support and exchange that I think helps each of the individual folks that are doing the LCA studies to get the work done. And I think it would be really positive if we constituted another cohort. Maybe these aren't the pilots, they're the next cohort of studies. Is there any plan to do that?
That will be up to the new DAR group that forms conveniently in July, which is when the first pilot study is concluding. So I think depending on the results that are found there, if people want to do additional studies from that group or take on a new cohort of studies as you're referring to, that would be up to the new DAR group. We're looking forward to some of the ideas that that group comes up with when reforming.
We've got a hand raised, Javier. There you go. You're off mute. Go ahead.
No, we still can't hear you. Oh, maybe we can. Okay.
There you go.
Yeah.
How about now?
Yep.
Yes.
Can you hear me now?
Yes, we can. Go ahead.
Perfect. One thing that I was discussing just this morning for a project that we didn't talk about at all today is the refrigerants. And I know that they're a huge part of the MEP equation. Is there any sort of movement on that? And what should we look for or recommend to clients when we're talking about that specific piece?
So if you want to go back in the forums, we've had, I think, 1 or 2 forums dedicated solely to refrigerants in the past, and discussing different strategies around next-gen refrigerants that you're able to use in certain pieces of equipment. We've talked about centralized versus decentralized system. The policies that are in that space are things like the Kigali Amendment, the AIM Act, the B1 section of the guide does go through some of the nuance around refrigerant leakage, and because that's really the problem. If it stays close to the system, it's not as much of a problem. So I would say reduce leakage whenever you can. Try to switch to next gen refrigerants and kind of looking at the GWP values, the GWP 100-year values against some of those different refrigerant types like R410A. You'll pretty quickly realize like where you kind of need to make those transitions. I'd say speak to your manufacturing partners on projects as well to see what they have available, what they will have available in a year or two's time. The US has been a little slow in terms of adoption there, but we're making way also in terms of projects that were in place. I'm actually curious about their status right now around tracking actual refrigerant leakage, because that's something that we're very curious about as well by different system types. What is the leakage in actual figures for projects in the US and different MEP system types? So,
and can I just do a little short follow-up in terms of, are you seeing a better landscape in US versus Canada? I know Europe for sure is better in some of these things, but do you think it's better for the Canadian environment right now, or is Canada catching up a little bit?
I can't speak to Canada. I'm not sure if anyone else in this group would want to. I know in terms of refrigerant tracking, Europe is far ahead of us in terms of leakage rates, in terms of adoption of next-gen refrigerants. Europe's also pretty far ahead, but we do have many more options available to us now in the US. So if you ask manufacturers, you should get a positive response.
Okay, good to know. Thank you so much.
I want to emphasize something that Kaylee said, and it really came sort of clear to us as we did the guide and the study of Wymer Hall. The leakage is much more profound impact in terms of whole life carbon than the global warming potential of the refrigerant itself. If you have a system that leaks a GWP of 1,000 at 10 times the rate of a system that leaks GWP refrigerant that has or refrigerant that has a GWP of 2,000, it's not better to have the lower refrigerant. It's better to have a lower leakage rate. So it's the other thing that is really a pretty light bulb over our heads is that there's a fair amount of disparity among manufacturers of the same equipment type using the same refrigerant in the total charge that they put in their equipment pounds of refrigerant per ton or BTUH of delivery capacity. And we didn't really understand that because our design community hasn't been particularly concerned about pounds of refrigerant per ton. That they just pick up, you know, who was the last manufacturer's rep that came in and bought them lunch. So getting your design teams to think about those aspects might change how they select equipment.
That's a really good point. Thank you.
Any other questions from the group?
I think just one more point about the volunteering for the different working groups and steering committee and advisory committee was brought up when we were putting this together, that I think is important to recognize and be transparent about. This effort does not have a staff member. So while Architecture 2030 is going to host the initiative through our 501c3, we do not have the current resources to support it with our staffing. So the staff member de facto in the last number of years was provided as Andrew as a volunteer through CLF. So this will continue to remain, yes, and congratulations, and thank you for Andrew for doing that, for all the great work that CLF also provided as in kind through that effort. But there's no grant funding here. That's why we are soliciting donations to support a budget to hire staff to support this effort. And again, everything that has been done here to date has been through volunteers, like the folks that you're hearing from on this call. So that will continue. Moving forward, even under Architecture 2030's umbrella. I don't want to give folks thinking that we have a ton of resources here that we're going to be able to throw at this. We don't. So I want to be transparent about that, but we are supportive of this effort and we will do what we can, just like CLF did, to support the effort. That said, fundraising and capacity building through volunteerism is how we're going to move this forward. So as Andrew said, if you can talk to your firms or yourselves are interested in donating, that will help us build a budget to hire staff to grow this effort, to do a lot of the work that might be done now by volunteers through these various working groups that we're establishing in July. So it's one or the other. We either need the funding to hire a staff to do the work, or we need your help to do that work. And so please, if you can do both, or if you can only do one, now's the time to act. Let's go ahead and move forward with it. But I wanted to be transparent about that. There's no magic pot of money here at Architecture 2030 that's going to fund 2 staff members to do the work that we know we need to do with this effort. So throwing that out there. Thank you.
All right. No one has anything else? Then happy to conclude here. And thank you all so much for downloading the guide, sharing the guide, attending this forum. We wouldn't have been able to do any of this without the community that we have around us. So thank you all.
Thanks, everybody.
Thank
We
you.
have no
Thank
shortage
you.
of guides. You keep downloading. There's plenty more where those came from.
By the way, we're up to 430 downloads by the end of this meeting,
Beautiful.
which is amazing. Bye, everybody.
Everyone.
Bye.